Okay, hi and welcome. Today we'll be talking about multiplying and also doing the reverse, which is factoring polynomials. Now, we're not going to do any complex factoring. We'll actually be working with some simple greatest common factor type of factoring, okay? Alright, so before we start, let's talk about the terms. Monomial just has one term. Polynomial has three or more. You can also say polynomial is like a binomial, or it just has more than one, is what it is. Alright, now factoring is just looking at all the numbers that multiply to get something. So, rewriting a number as a product of smaller terms. Okay, so in other words, if we were factoring 20, it would be rewritten as 5 times 2 times 2. So we broke it apart like that. If we were rewriting x to the fourth, that would be x times x times x times x. Okay, so that's factoring right there. All right, and usually when you're looking for factoring, you're looking for like the greatest common factor, or you're looking for a factor of binomials. And I'll give you a nice little hint as to what to look for with factoring and stuff. Okay, so first off, multiplying. Okay, distributive property is always the king, especially if I can spell right. Distributive property. Okay, and so like for example, 2x times 3x squared minus 4x parentheses. Okay, what we would do, let me get it. We would distribute the 2x to each part, and then we would be able to get the 6x cubed minus 8x squared. Okay. Now the reason why this becomes 6x cubed, 2 times 3 is 6, obviously. 1x and 2 x's make a total of 3 x's. That's why this goes up to x to the third. Then 2 times negative 4 is negative 8. X times x is x squared. We just move on from there. Okay, now a common mistake most people do is when they do x times x squared, sometimes they forget to increase it to x to the third because they don't see the exponent here. So remember, exponent here, we add the exponents, that gives us this 3. So just don't forget that little trick. Okay, so distributive property, now this would be a monomial and a binomial. You could do distributive property with a monomial and a larger thing. 3x to the second, parentheses, 5x squared minus 12x to the first, and plus 15. There we go. Okay, so now when you're using distributive, don't forget to just multiply by all three terms inside. Okay. Alright, and so what we get is 15x to the fourth, because 2 plus 2 in the exponents is 4, minus 36x to the third, plus 45x to the second. Okay, and voila, that's pretty much it. All you need to do for this. Now, there is another way of actually doing this, and I'll show you that. Okay. Alright. Alright, and this method is called the Punnett square. Okay, and what you do is you write along the top, and this actually helps when you're multiplying by bigger monomials. But what you do is you're going to take these and multiply it, and it's almost like you're finding area, except you're not really, but you are. You know, it's a tricky thing. Okay, so you multiply each one. Oh, and this should be actually a minus 4. I'm sorry. Should have that minus there. There we go. Okay, so this should be minus 8x squared here. And as you can see, I still get the same answer. All I need to do is rewrite it out of the box. Okay, and I can do the same thing exactly with here. Now, with the Punnett square, I like it because I can organize all my information and I don't forget to multiply anything. The one trick that a lot of people do, though, is they unfortunately add. So someone might go, oh, this is 5x to the third. No, do not add to get inside the actual box. Okay, you only combine or add after you multiply everything, and then you can just go ahead and combine it by addition. Okay, and then I would just rewrite it as this. Okay, so let's go over some more type of problems. Alright, so we're going to multiply two binomials. Now you guys normally know this as as a FOIL, and you just do first, outside, inside, last. I'm not going to teach you a new method right here, but I do want to teach you a method, Punnett squares, and actually just multiply to get the stuff inside. So I would multiply the 2x into 3x squared, and so I'd get 6x cubed. Okay, the 2x and the 4x get me 8x squared. Okay, the negative 5 and the 3x squared get me negative 15x squared. Okay, and then right here the negative 5 and the 4x get me negative 20x. Okay, and then what you can do is you can just rewrite everything outside. So 6x to the third plus 8x squared minus 15x squared minus 20x. Okay, and then you will notice, like, oh, well, geez, these two are like terms. Let's go ahead and add those. Okay, and as you can see, that's how last lesson is blending into this one. This one turns into minus 7x squared minus 20x. Okay. All right, now it doesn't matter what order or what side you put it on. You could actually put the x to the third over here. You could put the terms over here, and then the minus 9. You do have to put the minus signs with the ones that do have it. So if you pretend like this is x cubed plus minus 9 right there, that first part, then that will make more sense as to why I'm writing minus 9. But I just like to go, oh, use the operation with whatever it is. Okay. All right. Now you can also put the other stuff underneath. So this would be 2x squared. Okay, right there. This would be 5x. And then this would be minus 12. Okay, so we multiply everything. So this should become 2x to the fifth. Okay, 5x times x cubed is 5x to the fourth. And then this is going to become minus 12x to the third. Okay. All right, and then I go down here, and now I'm going to multiply by negative 9. So this is going to become minus 18x squared, because we're not changing the x's or the variables right now. This is going to be minus 45x, and this is going to be positive 108. Okay. All right, now if you're a very astute watcher, you've probably already noticed a little bit of something, that all of these are different variables, so I'm not going to be able to combine any of them. Okay, so this is 2x to the fifth plus 5x to the fourth minus 12x to the third minus 18x to the second minus 45x minus, or plus 108. Okay, and voila, I have my answer. Everything. Okay, now we'll talk about greatest common factors. Okay, now greatest common factors is just the reverse of what we've done. Okay, so we've multiplied in to get the answer. Now what we're going to do is we're going to divide out. Okay, we're going to actually divide out the common terms of certain ones. So this is just greatest common factoring. Okay, and this is the first step in a long line of factoring we're going to do. So like something like this, 15x to the third minus 12x to the second plus 18x. Okay, now if you notice each one of these, so since we multiplied to usually get in, we're going to divide to get out now. Okay, so I'm going to divide each one of these by their common factors. So what number goes in each? 3 does. So I'm going to divide out of 3 out of each one. So I write this as a reminder to remind myself, like, okay, I need to divide out the 3, I'm not done. Now if you also notice, I have x's in common with each. Okay, and usually the rule is like, okay, what's the least amount of x's I could bring out of there? What's the greatest amount of x's I could bring out of all three of these? And now it'd be just, well, they all have at least one x, so let's bring out that x. So I write the x next to the 3. Okay? And what I'm going to do is when I rewrite my answer, I'm going to have 3x in front of the parentheses. Okay? And then I'm going to do the division to get the stuff inside. So 15 divided by 3 is 5. And then x cubed divided by x is x squared. Okay? And then negative 12 divided by 3 is negative 4. X squared divided by x is x. And then this is going to be 18 divided by 3 is 6. And x divided by x is just 1, so voila. I've actually factored out the greatest common factor. Now, a trick you guys need to know is that whenever you're dealing with something like this, x minus 7, you'll learn this later. X minus 7, leave it alone. You don't have to factor out anything. Because technically this is, these don't have a common factor. The common factor would be 1. Okay? However, there's a math trick that really helps you out with the next section, which is when you're dealing with something like this, 7 minus x. Okay? So, what I recommend is take out or divide everything by negative 1 as your common factor. Because if you do that, it'll just get you out of some really sticky jams in algebra later on. So if I factor out the negative 1, voila, look at this. I now have what was up here, but instead of a 1, it has a negative 1 in front. Okay? All right. This will help out immensely, and this is a greatest common factoring trick that you'll use all the way up to calculus and pre-calculus and trig and all that stuff. Okay? All right. So that is it for multiplying polynomials and also doing a little bit of greatest common factoring. If you guys should have any questions, feel free to ask me. I'll talk to you later. Bye.